So let's do these last two problems. So the first one that we want to do, we want to do the square root of 72 n to the power of 7. Um, so you can pause the video if you want and try them out. I'm going to go ahead and finish them. So this you can rewrite it as, well, 72 can be rewritten as 8 times 7. Okay. Oh, no, that's wrong. 8 times 9. And then there you have 7 n's. So you have 1, 2, 3, 4, 5, 6, 7. Okay. We can further decompose the 8 as 2 and 4, and then the 4 as 2 and 2. Same thing with the 9, we can decompose it as 3 and 3. Okay, and now what we want to do, we want to take pairs because it is a square root. Now be very careful, because this is a square root and it's an even root, we're going to have to add absolute value to whatever we take out. So here we have a pairs of 2. So I'm going to take out a pair of 2. Then we have a pair of 3s. I'm going to take that out. Okay, these numbers are already positive, so you don't need to do it. You don't need to add absolute value. Now, how many pairs of n's can I take out? Well, here's one pair. Here's another pair, and here's another pair. So there's 3 pairs of n's, so n to the third power. Now we have to add absolute value here because it is an even root. Okay, now what's left over in the inside? In the inside, we just have a 2 left, and then we have 1 n. So my answer is going to be 6 absolute value of n cubed times square root of 2n. Okay, and this is going to be my final answer. Okay, now after a while, you will notice a couple tricks when you take stuff out. You don't need to write all 7 n's, all 20 a's, or whatever. You'll notice a couple tricks of the more problems that you do, okay, that you don't need to memorize all of it, okay? All right, so now let's do this last one, part B, the cubed root of 16 x to the 5th power, y to the 7th power, divided by 54 x squared y squared. So there's many ways that you can do these types of problems. I'll show you one way, and then I'll show you the other way. Okay, so one way that you can do is you can deal with both the top and the bottom separately. So this is the cubed root of 16 x to the 5th power, y to the 7th power, divided by the cubed root of 54 x squared y squared. So you can deal with both of them separately. Okay, so now let's put the bottom part. So the bottom part, I'm sorry, the top part. So the top part, I have 16. 16 can be decomposed as 4 and 4. So this can be 4 and 4. And then these two can be decomposed as 2 and 2. Okay, so basically I have 2 times 2 times 2 times 2. I have 5 x's, 1, 2, 3, 4, 5, and I have 7 y's, 1, 2, 3, 4, 5, 6, 7. So you can write them all out. And then the bottom part, 54, this can be decomposed as 9 and 6, and then 9 can be decomposed as 3 and 3, and 6 can be decomposed as 3 and 2. Okay. And then you have 2 x's, and then you have 2 y's. Okay, so now let's start taking things out. Now we don't have to add absolute value here because we're taking things that are out of an odd root, so that's not something that we need to worry about. Okay, so let's take out the triplets. So here's a triplet of 2's. I'm gonna take this whole thing out. Okay, so I'm gonna take out 2. Okay, then what about my x's? Here's a triplet, and that's it. So this is just one set of triplets of x's. Okay, and what about y? So here's a triplet, here's a triplet, so that's 2 sets, so it's y squared. Okay, and what's left over in the inside? Well, in the inside, you're left with a 2, everything that's not circled. You're left with an x squared, and you're left with 1y. Okay, and in the bottom, what am I left with? Well, I have a pair of 3's, or a triplet of 3, so that's going to come out. I cannot take any x's and I cannot take any y's. So what I'm going to be left with is the cubed root of 2x squared y squared. Okay, now all of this, if you notice, all of this is under the cubed root. Okay, so all of this thing is still under the cubed root, so I can write it a specific way. So this is how I'm going to write it. So everything on the outside, that was just this 2xy squared divided by 3. That's what I have. Now everything in the inside is anything that has the cubed root, which is going to be the cubed root of 2x squared y divided by 2x squared y squared. Notice here that the 2's are going to cancel out and also the x squares. So what I'm left with, I'm going to be left with 2xy squared divided by 3. Here I have one y on the top. I'm left with one y on the bottom. So it's going to be the cubed root. Now I have nothing on the top, so it's just going to be an imaginary 1 divided by 1y on the bottom. Okay? Now typically we don't want the y's on the bottom, so I'll show you later how to fix this. Now there's another way that you can do this problem. And you'll see that when I do it this way, it'll be a little easier, but it won't look like you got the same answer, but actually it is the same. So let me show you the other way, which I think might be a little easier. So the other way is just taking the cubed root of 16, what was it? 16x to the 5th power, y to the 7th power, divided by 54, x squared, y squared. Okay, let me bring this down. Okay, so you have this part. Another way that you can do it is, before we separate everything into the cubed root, just simplify everything under the cubed root. So notice that 16 and that 54, that 16 and that 54 can actually be reduced into something different. So 16 and 54 both can be divided by 2. So how many times does 16 divide into 2? Well, that divides into 8 times. So this can be 8 over 54 divided by 2. This gives me 27. So I'm just reducing the fractions. Here I have 5 x's and I have 2 x's here. So what we can do here is use some properties of exponents. So remember, when I had a property of exponent, when you have x to the n power divided by x to the n power, what you can do is that you can subtract the exponents. So what I'm going to have is x to the 5th over x squared. This is going to be x to the 5 minus 2. And x 5 minus 2 is going to give me x to the 3rd power. So this is going to be x to the 3rd power. Here, same thing. I'm going to take y to the 7th divided by y squared. This is going to give me y to the 5th power. Okay. All right, and all I got to do now is take the cubed root of everything. Okay, so on the top, basically I have the cubed root of 8x cubed y to the 5th power divided by 27. Okay, now I can go ahead and put it separately because I reduced in the very beginning. So I'm going to take the cubed root of 8x cubed y to the 5th divided by the cubed root of 27. Okay. So on the top, the cubed root of 8 is just going to be, so let me write everything out. Cubed root of 8, this can be decomposed as 4 and 2, and then 2 and 2. So it's going to be 2 times 2 times 2, 3 x's on the top, 5 y's also on the top, 1, 2, 3, 4, 5. And then on the bottom, 27 can be decomposed as 9 and 3. Okay, 9 times 3. And then this can further be decomposed as 3 and 3. Okay, so now we're looking for triplets. So here is a triplet of 2s. So that's going to come out. So I'm left with a 2. I have a triplet of x's. So the whole thing is going to come out. The y's, a triplet. I have 1 there. So it's going to be 1. And then here I have 3 3's that I can take out. It's going to be divided by 3. And what's left in the inside? The cubed root of y squared. Okay, so this is the answer. Now, if you compare both this one with the blue one here, they don't look like they're the same, but actually they are. And in the next couple of videos, when we talk about rationalizing the denominator, you'll see that these two problems are actually, these two answers are actually the same thing. But for now, we'll just keep it as a given, and then we'll revisit this a little later.